Hey Techno Studs! When a packet comes into your router takes a look at that packet and looks at the destination IP address inside that packet. Then it makes a determination of where it needs to send that out. Well, it makes that determination based off of what it finds in the routing table. And what does it find in its routing table? A bunch of routes. So let's take a look at what information is found inside of a route. In this video, we'll start out by talking about what a route is. Once we determine what a route is, we'll take a look at a routing table where we'll see a lot of different types of routes in there. Then we'll talk about route information, what information you would find within that route. We'll take a look at the types of networks there are. Then we'll take a look at what a child and a parent route is. We'll take a look at an IPv6 route, and we'll wrap things up talking about what a host route is. A route is a direction or mapping to a network. So let's give a little example here. In this network diagram, I have three routers. We'll call this router 1, router 2, and router 3. We also have a layer 3 switch. So this layer 3 switch acts as a router as well. And so off of this layer 3 switch, we have several VLANs, one of which is this VLAN 10. VLAN 10 has an IP address range of 10.1.10.0/24. So that is its network address. And let's say that all these layer 3 devices, so these three routers and the switch, know of this network. So let's take a look what that looks like from a route perspective. On this route, this layer 3 switch right here, that's a directly connected network. And so within the routing table, it would show a route to that directly connected network. However, for router 1, this network right here is not directly attached. And so it has a route, but the route points to this switch. Same thing with router 2. Router 2 understands this network of 10.1.10.0 and knows how to get to it, but it knows that it gets through router 1. And then router 3 understands it gets to that network through router 2. So these routes are specific to the router. They're different. It's the same network pointing to the same network, but they point to different devices depending on where they fall within this network. So that is a route. It's a pointer, a mapping towards a network. So here's a couple examples of that. So this is off of that layer 3 switch. We can see that because it's a directly connected network. It has information about that network and the fact that this is directly connected. On this router, we can also see that it has a mapping for 10.2.0.0/24. So that network shows up on this router as well. And it has a route that points to 10.240.0.2. That's the next hop. So if information comes destined for this network right here, it will then send it to this router right here, which is the next hop. These routes are stored on a routing table. Routing tables can be found on each of your layer 3 devices. And what will happen is a packet will come into that router or layer 3 device. That router will then reference the destination IP address with the list of routes that it has, determine what the best route is, and then send it on its way. A couple pieces of information that you should consider when this is happening is not all routers necessarily have all up-to-date information, which could be problematic in some cases because each one of these routers makes a determination of where it's going to send this packet on to next. And the other thing to keep in mind, and we've experienced that while going through this course, is that just because it knows how to get to a destination network, it doesn't necessarily know how to get back to where that packet came from for a reply. So just because there's communication across this network one way doesn't necessarily mean that there's communication across it the other way. So what will you see as part of a route? Well, first thing that we see is that it has the network address. So that's the network address that it's going to associate with. So that's one thing that we see within our route. Another thing that we see in here is what is the next hop. So, and in many of these cases, it's by IP address. So we see that in here. We also see some directly connected networks in here. So if it's a directly connected network, you can see that it will specify that. Not only does it have the next hop IP address, it also has the exit interface. So for these right here, it's VLAN 9. So VLAN 9. We also see some other information in here. We see this 110 right here. That's what's called an administrative distance. You can see that we have the administrative distance of 1 for this statically assigned route. And then for this OSPF routes, we have an administrative distance of 110. And we'll get more into that a little later. We also see the cost to each one of these networks. So this is the cost that it takes to get to each one of those networks. And then the other thing that we have is the timestamp. And this is how much time that there's been since this route was learned. And so this is representative of how long that this device has known about this route right here. So there's some information that you would see for each one of these routes within the routing table. There are 3 different types of networks that you'll see. One of them is a directly connected network. Directly connected network are all of those networks that are directly connected. So for this switch 1, we have one directly connected network between the router and this switch, and then all of the VLANs that are part of this switch is also directly connected. Or for this router right here, these 2 on each side of it would be a directly connected network. Next, you have a remote network. So a remote network is something that is not directly connected. So for this switch right here, this switch would have this would be a remote network, this would be a remote network, and this would be a remote network. So in this example right here, it would have 3 remote networks to it. And then finally, you may have a route that points to the internet, or just in this case right here where we call this a stub route, it's the end of the line essentially. Then this switch then points out to this router, and maybe we have just a default route that says if you need to communicate, send it this way. And so that's a default route. It's a catch-all. It's just like a default gateway that you would set on your computer. You may hear some terminology out there such as child and parent routes. So there's a level 1 route, a level 1 parent route, and a level 2 route. So first of all, level 1. If it's a level 1, that is anything that is justified all the way over to the left. That's any route that comes all the way to the left-hand side. So that would be 3 routes in this example right here. This route, and this route. All are level 1s. So these 2 are level 1s. And then this one right here is a level 1, but it's also a parent route because it has these child routes to it. And so this would be a level 2 child route. And this is something we would just see within IP version 4. And it really, what it does is it designates anything that's subnetted within here. So any subnetted routes, that's where you're going to see a child and parent route. However, when we get to IP version 6, they never had classful routing. And so you don't see that same structure with IP version 6. This is an example of a show IPv6 route command showing the routing table for IP version 6. And we can see that it's all at the same level right here. You see a static route in here for our quad 0, so that's the default route that we have. We still have administrative distance on each one of these. We still have a metric on each one of these. We have the destination network and how to get to that network. So we see all the same components on an IP version 6 routing table. It just looks a little differently. It doesn't have child and parent routes. And then one last call out for a host route. A host route goes to just one specific host. It's anything where you see the network mask is all 1s or the prefix is 128. So here's a couple examples of that where we see 10.1.10.34/32. We're specifying a specific host there. And same thing for that IP version 6. The prefix length being 128 means that we're doing an exact match. So that is when you'd see in a routing table going something going directly to a specific host and not necessarily a range of hosts or a network, a whole network. There you have it. We talked about what is a network, what is a routing table, some information you would find in that routing table and in each of those routes. We talked about the types of networks there are, whether it's a remote network, a directly connected network, or the default route. We talked about the child and parent routes that you would see within your routing table, an IPv4 routing table. We also take a look at a glance at the IPv6 routing table, and we wrapped it up by talking about what a host route is, going directly to a single host.